Okay, so I'll start with the ecosystem. So this is the most of the telecom or the open RAN ecosystem revolves in these 6 major parts, but we will add another more. No? So kasama dito includes Telecom Infra Project, the ORAN Alliance, and the other key RAN open groups like the Open RAN Software Community, Small Cell Forum, and Open RAN Policy. Hold on. Sorry, I'm switching slides now. Hold on. Ito pala. Okay. Okay, ito pala yung mas updated. Okay. So these are the open RAN groups and initiatives now. So mainly, it includes 3GPP. Okay, so 3GPP is, ang meaning ng 3GPP is the third generation partnership project. So it was established in 1998 and it defines yung mga standards ni 3G, 4G, and even the 5G standards. So including the functional split, when we talk about split, functional split especially in the architecture of Open RAN. Radio access network, and then the Open RAN, no? And the F1 mid-haul between the DU and the CU. So itong ginagawa ni 3GPP. So usually lahat ng mga standards natin na ginagamit sa cellular falls in the 3GPP standard. And then we have Telecom Infra Project. So Telecom Infra Project or TIP was established in 2016. Mga bata pa sila, no? Open RAN, this was the first organization that conceived Open RAN. And TIP has multiple Open RAN product implementation as well, and project groups. And this was founded by Facebook, also known as Meta. So si Facebook is not only a social media company, but also massively involved in Open RAN. So they have this Telecom Infra Project. So when you hear about Telecom Infra Project or TIP, kaakibat lagi niyan si Meta or si Facebook. And then we have the ORAN Alliance. So later on we'll discuss further, no, kung sino yung mga yan. We'll look at it muna in a macro scale. So ORAN Alliance, this was established in 2018. And they are the one who are developing architectures and specifications for Open RAN. So 3GPP for the cellular standards, mostly 3G, 4G, or even 5G. And then all the specifications outside the 3GPP, but included in the Open RAN system, was handled by ORAN Alliance. So there are no overlaps, no, of specifications. And then we have ETSI. ETSI is a European Telecommunications Standards Institute. So they are also involved in promoting Open RAN adoption in Europe. Okay. And then we have the GSMA, or the GSM Association, that represents the global telecom operators. And they are helping operators to commercialize Open RAN. And then we have also NGMN. Okay. So NGMN is next generation mobile networks. So they are collaborating with the ORAN Alliance to accelerate the standardization and adoption of Open RAN for 4G and 5G. So you will hear them most of the time kapag kapag kausap natin mga operators natin dito. They are actively joining this NGMN forum and workshops. And then we have this Linux Foundation. So this is a non-profit consortium created in 2020 by Open Source Development and the Free Standards Group. So they promote this standardized Linux for commercial use. They are the software development for Open RAN. So most of the software or interface that we will be encountering using Open RAN will be on a Linux base. Okay. ONF, the Open Networking Foundation. So they are contributing to the SD RAN to support the ORAN Alliance that are defining the vertical disaggregation standard, including the RAN intelligent controller. And then you have the SCF, the Small Cell Forum. Okay. These are developing standards for small cells. So ito yung mga pang-indoor. Those are the radio access network that we deploy inside the buildings, malls, or even the coliseums. We call those deployment as small cells. And they are developing this kind of forum or standards of Open RAN with the small cells in mind. So they're really focusing on the small cells, no? So including the FAPI and the NFAPI, no, or the Network Functional Application Platform Interface. So these are the parties, no, that work together to avoid the duplication of work and use the same standards, and then it supports each other and then support the development, and they encourage adoption. Now let's go to one of the main contributors. Of course, the 3GPP. So 3GPP is a third generation partnership project. So it unites the 7 telecommunications standard development organization known as the organizational partners. So if you want to know more about the specifications of 3G, 4G, or even 5G, just go to 3GPP. And if you are one of the operators and you want to check if your vendors are complying the 3GPP standards, so go to the 3GPP, download the document, and then you can see if they're complying. But most of the vendors, of course, are complying the 3GPP. Actually, most of them are on top of 3GPP. Okay, so 3GPP sets the standard. Okay, so they provide their members with a stable environment to produce the reports and specifications that define these 3GPP technologies. Okay, so these are the 3GPP. So you can go to 3GPP, so you can just check. For example, if you're interested what's happening in 5G, that we call now the 5G Advanced, which is the release 18. So what are the technologies involved in release 18? Because the first 5G was released was in release 15. So we already completed almost 3 releases. So when you say releases, these are similar to your iOS or Android upgrade. Okay, so there are additional technologies or functionalities that are being added to the existing or the basic configuration of your system. Okay, so those are this is the 3GPP. Next in line is Telecom Infra Project. As mentioned, this was founded in 2016 by Facebook or Meta as an engineering focus collaborative technique for designing and implementing global telecom network infrastructure. Okay, so TIP is led by board of directors comprised of founders from the technology and telecom industry. So you can just also browse the telecominfraproject.com. So you will see as well what are the different activities involved. Most of those activities that is being done by Telecom Infra Project are what we so call the Plug Fest. So Plug Fest, if you compare it here in the Philippines, you bring your dog to another dog owner and then you plug them together. Okay, if they work or not, if they will be working or not. No, same thing with the Plug Fest. No, you bring your equipment, or you bring your software, and then let's test it together. Okay. Iba yata sa Pilipinas. We bring dogs. Okay. Okay. All right. So, Telecom Infra Project, let's just share with you some videos about Telecom Infra Project, so you will learn more about who is Telecom Infra Project. So let me just share the screen.
Evenstar's goal is to accelerate the adoption of Open RAN through product innovation and partnerships, enabling mobile network operators better opportunities to provide more affordable and higher quality internet for everyone. Open RAN allows operators to choose best-of-breed components from an expanding number of technology partners.
The Telecom Infra Project's Open RAN project group is aggregating operators' requirements as well as assisting in integration, testing, and interoperability of EvenStar solutions.
The EvenStar program is expanding the radio, DU, and massive MIMO ecosystems, and we are working with our partners to bring these Open RAN solutions to market.
Our participation in the program enables us to build radio products that scale globally. By leveraging a platform approach to Open RAN, we've been able to reduce component costs, improve time to market, and lower the cost of ownership for operators. This partnership greatly accelerates our efforts to deliver open and programmable networks that meet the needs of our customers.
Working with key silicon providers, our goal is to increase performance while lowering power and costs, enabling state-of-the-art Open RAN radios, DUs, and massive MIMO products.
We look forward to continue innovating, building partnerships, and embracing the challenges ahead to advance Open RAN networks to support the metaverse and beyond.
Ayan, no? So yan that was Meta, no? Supporting Open RAN under the Telecom Infra project. So yung project nila is si EvenStar. Okay. Ayan. So next is ORAN Alliance. So ORAN Alliance is as a group of telecom companies that aim to improve their performance and openness of their network. So they call for more intelligence in the network through information collection of these virtualized network elements. And artificial intelligence, or AI, as we experienced or learned from the previous sessions in AI, NLP, and ethics and governance. So this new technology will be incorporated or integrated with the Open RAN. So the main reason is that wala pala akong video, no? So the main reason was that because as we progress through the technology from 4G to 5G, you will see that the more our technology becomes more advanced, it becomes more complex as well to manage. It's very difficult to manage because, for example, in 5G, because in 5G, we don't have we have a lot of frequencies. We have a lot of use cases like EMBB, URLLC, or MMTC, and then you have what we call the NSA or SA. And then we have different features, okay, different functionalities. So it becomes more difficult to handle for a mere engineer or a group of engineers to handle it. So there must be an intelligent entity or a network of intelligent system that will help us how to manage and maximize the potential of the network. Because sometimes even the network has this great potential. It is not hindi natin ang tawag doon is hindi natin na lalaspag yung system, no? Kasi it becomes more complicated, no, if there's a problem that may arise. So we are using this kind of network technology like artificial intelligence to handle it. Okay, and it will also give more time for engineers to sleep and more time to rest and relax. Okay. All right, so these are the ORAN Alliance. So the ORAN Alliance is formed in February 2018 with the goal of promoting an open and interoperable, open and intelligent RAN system. So it's the second organization driving the Open RAN movement. So ang first is si TIP or si Telecom Infra Project, and then second was the ORAN Alliance in 2018. So if you will compute, almost almost 6 years pa lang sila. So mga bata pa si ORAN Alliance. And ORAN Alliance was came from the marriage of bata pa talaga, from the marriage of two distinct groups, the CRAN Alliance, which are China Mobile and other Chinese vendors, and NTT Docomo. Okay, so and other mainly American vendors. So they formed together to bring ORAN Alliance. So the founding operators are AT&T from the US, China Mobile from China, Deutsche Telecom, NTT Docomo, and Orange, no, in France. Okay, so let's see, no, some promotional video from ORAN Alliance, so you will know more about this organization. And I encourage you, especially those young professionals, or even the professionals who want to jump in, no, in the ORAN deployment, particularly not only here in the Philippines but also in other countries, no. So this is the video from ORAN Alliance.
Transforming radio access networks to be open, intelligent, virtualized, and fully interoperable is not a far-off vision. The ORAN Alliance has made this vision real. Since 2018, the adoption of the ORAN Alliance by the industry has been incredible. It has grown to a worldwide community of operators, vendors, and research and academic institutions jointly developing a sustainable ORAN ecosystem. Through expanding traditional mobile networks, the ORAN Alliance has created its ORAN architecture to become a foundation for truly open and intelligent radio access networks. The ORAN architecture improves the RAN in several areas. First, the ORAN architecture supports disaggregation of software from the hardware and network virtualization. Underlying open reference design hardware and the O-Cloud provide a high-performing and scalable computation layer. Second, the ORAN architecture is based on well-defined open interfaces to enable a multi-vendor, interoperable supply chain ecosystem. Third, the ORAN architecture empowers mobile networks through artificial intelligence and machine learning. ORAN networks can self-optimize to ensure the best possible service for the end customers, and automated operations and maintenance enable more efficient network rollout and operations. Defining the complex ORAN architecture is a step-by-step process, resulting in hundreds of technical documents. To ensure compatibility and to avoid duplication of work, the ORAN specification effort builds on common standards and cares about alignment with other industry bodies. ORAN specifications serve as a basis for open software reference design. The ORAN software community hosts developers brought in by many ORAN players, cooperating on tens of software projects. ORAN specifications in open software are enabling a broad industry ecosystem. Companies of different sizes and competencies can use them to create their innovative and competitive open solutions. In addition to specifications, ORAN Alliance supports the ecosystem in testing and integration. ORAN Global Plugfests allow companies to demonstrate component functionality as well as multi-vendor interoperability. Moreover, the open testing and integration centers around the world will offer a collaborative and impartial testing environment. ORAN supports implementations using open source modules, proprietary modules, or any combination. Operators and suppliers can create different paths and approaches to implementing ORAN, optimized for their specific network and customer needs. The rapidly emerging ORAN ecosystem has enabled service providers on multiple continents to start field trials and commercial deployments, aiming to build significant parts of their networks based on ORAN technology. Open, intelligent, virtualized, and fully interoperable, ORAN-powered mobile networks will soon be serving billions of people around the world. The ORAN Alliance.
Yeah, join na, no? ORAN Alliance. Okay, so there are two high-level goals of ORAN Alliance. No? So openness, so they will enable small vendors to introduce their own services. Yeah, because not only in the Philippines but in other countries as well. So there are still coverage gaps. No, there are some coverage gaps that still needs to be filled in by not the major vendors, but also some of the small players or small vendors. And one of the best approach is to have them a more or cheaper solution, to implement this kind of solution, which is the open system introduced by Open RAN. So that is one of the goal, the openness. And then there should be an open source, open source reference design, so enabling faster and permissionless innovation. So if you want to innovate or add more functionalities or features in the existing system, so you can jump into the to the ecosystem. So that is for the open source. And the second goal is to automate complex networks, simplifying operation and maintenance and enabling a new era of network operations. So sino ba ditong ayaw ng automation, no? So meaning that's the main reason, kung bakit why we are including, for example, artificial intelligence in the Open RAN courses, because this will help us also do the automation, the intelligent entity or system, that will be embedding in our networks. Aside from giving the engineers more time to sleep and relax and more time for their gala, this will also give more space, for the system to bring the possibilities and the potential, to give better services to subscribers. Yan. Okay, kapag well-maintained talaga ang system. Okay. And I believe some of you may also experience that sometimes you have a signal but you cannot readily use the signal, because there's an issue on the resource allocation. Okay, so if there is somebody that or some network system that could manage that 24 hours a day without any complaint, yeah. So for example, a typical example would be a traffic light. Everybody, including me, get so frustrated, in the traffic lights that is let by some traffic enforcers to be function as a timer only. For example, there are traffic lights that functions as a 120 seconds before it lets you it will go signal, to green. So hindi nagbabago, always every now and then it's also always 120 seconds. And then the go time could be around 10 seconds or 20 seconds, no? So hindi siya effective, no? What if we will empower that traffic light with the artificial intelligence, with the camera that monitors, kung gaano nagpa-pile up yung traffic, and then it will decide on its own na okay, go, and then stop because nagpa-pile up na yung pila or yung traffic, and then simultaneously, real time nagde-decide siya on its own, like a digital traffic enforcer na nasa taas. Hindi napapagod, hindi naiinitan. Okay, so same thing, we would like to use that also in our network, that aside from not replacing the engineers, to help the engineers as well to think more innovations and different features na pwedeng implement sa network. So those are the goal, simplifying the operation and maintenance and enabling a new era of network operations. Okay, so they introduced this kind of ORAN architecture, but we will not go into details because we have a separate session that will be handled by Dr. Josil next week. Okay, but this is the ORAN architecture, that was introduced by the ORAN Alliance. Okay, so it includes the hardware, the software, and also the functionalities that will be implemented during the Open RAN. Okay, so this is a more simplified. It is a simpler or simplified version of the ORAN architecture. Okay, and in each architecture, you will see that there are specific working groups that are focusing on each system. Actually, this must be updated because there is another work group 11 that handles the overall security, because most of the people or some of the participants actually here might have a concern on the Open RAN security. So there's a specific group in ORAN Alliance technical working group that focuses on the security of the system. So that is, I believe, work group 11. Okay. So work group 1 will be is focused on use cases and overall architecture. Work group 2 is on the RIC or the non-real time and the A1 interface. Work group 3 is in the near real time RIC, and then work group 4 is on the open front hole interface. Work group 5 is the open interfaces like F1, W1, E1, and X2 interfaces. Work group 6 is on the cloudification and orchestration. Work group 7 is the white box hardware, particularly in the ORU and OCU and DU. Work group 8 is the stock reference design. Work group 9 is the open X-hole transport. And then work group 10 for the operations and maintenance and O1 interface. And then the work group 11 for the security. Okay. Yan. So that is the main players in the Open RAN, Open RAN system. So if you will see what is the main difference of TIP and ORAN Alliance, wala ba silang wala ba silang overlapping of responsibilities and tasks? So ORAN Alliance, as mentioned, they are the one who are creating and promoting and enforcing standards to guarantee that equipment from various suppliers may communicate with one another. If you remember in the video of ORAN Alliance, there is what we call the OTIC. Okay, so there are OTIC centers available worldwide. Ang pinakamalapit sa atin is the OTIC in Singapore. So they are the one who are testing this system, the hardware, the software, and their interoperability. Okay. And then while the TIP is more concerned with the deployment and execution. So they promote this, as I mentioned previously, the plug fest, and live deployments in the field. And they also developed the standards where TIP ORAN Alliance, where none exists, such as the front hole requirement. So the front hole requirement was not included in the 3GPP standard. So that's why ORAN Alliance took the wheel on that one. So they're the one who initiated the front hole standardization. And then the TIP naman, they allow for the Open RAN ecosystem. So they're building this ecosystem. You will see that there are laboratories. There are also support that there are also different supports coming from TIP to other operators or vendors to deploy, test, Open RAN system. Later, I will show you some samples. And it generates profiles for interoperability, and then on the TIP side, they guarantee the different supplier software and hardware equipment that works together using their plugfest. And the ORAN Alliance is mainly focused on the 5G and 4G solutions, while TIP is all Gs. When you say all Gs, it includes 2G, 3G, 4G, and 5G. Okay, so those are the main differences of TIP and ORAN Alliance. Now let's move on to the deployment of Open RAN. So why do we need to deploy Open RAN? As mentioned, not all countries are perfect. So in terms of coverage, not only the Philippines is part of this system. There are areas in the Philippines that's still not covered or not fully covered. So you're very fortunate if you belong to an area where you can enjoy around 10 Mbps when you try to do the speed test. But there are some areas that they don't even see in their phone the LTE signal. They can only see GSM or 3G. Okay. So connectivity are very essential. So if there's a lack of connectivity, If there's no connectivity, for example, in this area, you cannot see any cell sites. So there's a limited access in the remote areas. You experienced this during the pandemic, when you were enclosed in your house and then no signal at all. So you feel the frustration of not being connected. No, it's difficult to order Grab, and then it's difficult to contact the Grab driver. Okay, so connectivity is as if you watch the NEDA presentation yesterday, no, you can see that internet can be considered as part of the basic needs, no, basic human needs of us, no, and you will also see that connectivity, without connectivity, we'll have this social connectivity issues. Okay, you cannot watch our crush TikTok, no, you cannot like the pictures of our admired people. Okay, so aside from that, kidding aside, so we feel the lack of connectivity, especially for OFWs, that their families are located in far-flung areas. So as you, this is a reality in the Philippines, no, that most of the OFW come from those far-flung areas that try to to test their luck and find their better opportunities abroad, but their families are left behind in areas where there are no connectivities. Just imagine the loneliness that they're feeling. So they are isolated physically and then digitally as well isolated. Okay. So dati nga when I talk to my previous OFW friends, no, they mentioned to me that whenever they want to send a letter from Saudi Arabia and then send it to Philippines, it may take it took them 1 month, no, before they receive it. And then if they will anticipate the response from the family in the Philippines, it will take another 1 month, no, ganun ka hirap daw. So what they did is that they send a voice tape. So if you remember the voice tape, no, and then it's a lot of information. Now, OFW and families here in the Philippines enjoy the connectivity by merely just Facebook, Messenger, Viber, no, calling them anytime they want. That is if the connectivity is available. If the connectivity is not there, so that is an issue, a social connectivity issues. Okay. And imagine there's an emergency that happened in your barangay, and then you need an ambulance, or you need to call the barangay tanod. The barangay tanod is the one, like a mini police, no, but with the batuta, with the batuta on the side. Okay, so that's the barangay tanod for the foreigners joining here. We have this some kind of local police with the batuta on the side. Okay, so if there's an emergency, no, so you need to call somebody. So if there are no connectivity, it's an issue, right? It's very difficult. Not all of us can run as fast as other people, no, to go to the barangay and call for help. Okay, so emergency services, especially for medical services, and of course technological isolation. So we call it a digital divide. Okay, digital divide. So there's a lot of opportunities missing if there's no connectivity. So what we want is to have a connectivity like this, a simple single cell site, no, that will bring connectivity and enrich the experience of the population living inside the community. Okay, and one of those solutions, aside from cell site, aside from Wi-Fi, is the Open RAN. Okay, most of these areas are what we call the end site, no, or the last mile areas, which are beyond the last cell site that from a operator's network. So we can use Open RAN to deploy that, no, because in terms of planning, no, maybe there's a complexity. There must be a way to handle the complexity of handling these two networks and how to integrate this into an existing system, no? Because it's a different system. So we just need to deal with that kind of problem. We just need to find better solution, how to implement this, especially for a brownfield operator. Brownfield operator means they are these mature operators that already deployed new network. Greenfield operators, these are operators with a new network. For example, if now will be joining the fund, so they will be considered as a greenfield operator. So same thing with the Rakuten. So they are considered themselves greenfield operator. So when they build their network, so that's the first time they build the network. So they decided to go for Open RAN. So all of the system deployed by Rakuten in Japan and Dish in the United States are Open RAN. Okay. Okay, so we will not go back more on the Open RAN definition. You already know what's the Open RAN, and then we'll go to the deployment and trials. No, so where can we deploy or use Open RAN? So there's a lot of opportunities. No, so if implemented well, no, the Open RAN technology will lower the total cost of ownership in comparison with traditional RAN. Okay. So, for example, in Rakuten, as they mentioned and they broadcasted also, a Japanese company deploying an Open RAN 4G and 5G greenfield network in Japan. They reported a comparative reduction of 40% in CapEx and 30% in OpEx. If you will visit the Rakuten website, you will see those reduction of CapEx and OpEx. So when we say CapEx is a capital expenditure. So for those who are not very familiar of cell site, just imagine if you want to buy a car. So if you buy the car, the cost of the car itself, we call it the CapEx. Okay, so if you buy a Toyota Vios for around 1 million pesos, for example, no? So that is the CapEx. No? Now, OpEx is the operational expenses. So these are the monthly or the recurring bills or recurring expenses that your vehicle is getting. Example is the fuel, okay, maintenance, insurance, tire change, oil change, no, yeah, and bias driver. Okay, so that is OpEx, no, operational expenses. So in cell sites, like it's the same, no, for a network, it's the same as well. So when you first build the cell site, you need to pay for the tower, you need to pay for the equipment from the antenna, the cables, the RRUs, the radios, the baseband units, okay, the core network. So those are we call considered as CapEx, including the tower. And OpEx is for example, electricity, okay, payment for the land rental, payment for operations and maintenance, no? So payment for the fuel of the generator. So those are considered as operational expenses. Okay, so in total, we call it a total cost of ownership if you combine those two. So it is important to note that this TCO will vary, based on the selected architecture. Okay, so let me just give you an example. I believe I showed this already with you, because there's a lot of people saying, why in some areas there are no cell sites, and why in some areas there's a lot of cell sites, no? Because at the end of the day, we are calculating the business profitability of the site so that we can have this what we so-called sustainability. Sustainability meaning we have enough money to sustain the operation of the cell site. And when we say operation of the cell site, it means maintenance and then salary, salary of the engineers, and then other business things, that will help us sustain the operation of the cell site. So if you will see here, I created a simple Excel file. We call it the PP, no? PP means payback period. Okay. And then CapEx is capital expenditure. And then the revenue is the revenue per month, how much we earn from that cell site. Okay. And then the OPEX. So this is simplified because if you go for a telecom operator, it's a more complicated calculation. I just want you to show an overview. So it's not also the representation of the totality or the average cost for a cell site, no, but it's just a mere example, just for you to understand and appreciate what is capex and what is the opex. No? So opex is the operation expenses per month. So a sample calculation, for example, you have 4 sites here, and the capex is around, for example, no, if we will not go for 70%, so because this one already it's 70%, you know, yeah. So for example, no, in this site, you have 200,000 for the capex. So meaning that's the amount of money you need to build one cell site. So 200,000 US dollars. Again, this could change, right? It depends on the selected network architecture and depends on the configuration, depends on the area. It's just a mere example. It's not the actual numbers. And then the OPEX per month would be $1,000. And then if you have a revenue, for example, you are generating 10,000 US dollars per month. So the payback period is calculated like this. So the capex, okay, you divide it by the difference of revenue minus OPEX. Okay. So meaning if you analyze this simple formula, if you earn $10,000 more than the operational expenses, you might have a probable positive value, right? So meaning you have 22.22 months. So this means that to recover the 200,000 US dollars capex, you need 22 months. Okay, so that is how we calculate the payback period. And some indicators that might not be not be applicable to everybody, but in some cases, if the PP are greater than 36 months, meaning more than 3 years, it's not good, okay, or it's very too long to recover for a business. For example, if I build a telecom company, if one investment will not give or yield my initial investment in 3 years, it's too long for me, no? So that is PP. That is the meaning of how healthy. What is the metrics, no? If the PP is or the payback period is less than 36 months, we can consider it's a healthy PP. It's a good investment. Okay, it's a good business. And if the PP is, for example, less than 0, cannot recover the investment. So what does it mean? No? For example, my revenue per month is around $500 only. So it will give me a negative payback period. Meaning, luging-lugi ako. No? So the revenue that I get every month will only be paid to the OPEX. Pambayad ko lang ng kuryente or pambayad ko lang ng mga gastusin. Lugi pa ako. Abono pa ako. Okay. So there are sites like that, no? And if you are in that kind of business, you win some, of course you lose some. No? It depends on how you see your entire network. No? So there are some sites that are focusing on the regulatory requirement, and then there are sites that are really profitable. So you win some, you lose some. Okay, so this is the typical example of the PP calculation. I believe you I don't know, you understand this kind of calculation, so that you can appreciate now why there are some areas that we really need a cell site, but still we cannot achieve it. Okay, we cannot build something. It's because there's a impact of there's a business impact on that one. Now, if you want to go more deeper, I am creating something like this, no, because it's more on about the expected population. Okay, so for example, I just bring it down, no, because it's there's something we need we need to think more. So for example, I expected population is 10,000. No, this is a typical example. Yeah, typical example only. Okay, and 10,000, and then the potential subscribers is 95%, and the operator market share, for example, you are 3 operators or 4 operators, the market share is 40,000. So typical is you only have a target of 3,800 sites, 3,800 subscribers. And if those subscribers are using voice call, I can have a revenue of 400,000 per month. And then for data, I can have a revenue of 1 million per month. Now, if my capex or building that site, for example, this is not an indicative number. For example, you will build a site for 10 million, and then you have implementation services of 1.5, and then OPEX of 40. You can see that this is a very good investment. Okay, 6.79 per month. 6.79 months. So I can recover my investment in 6.79 months. Imagine if this becomes 1,000 population. Okay, 1,000 population, my return on investment will take around 86 months, right? So that's one of the impact. No? It depends how many subscribers are there, what are the services that we can offer to them, how much would be the services will cost. And of course, there could be an impact on this one. This is where Open Run will come in. Okay. For example, if we go for example, only 70%. If we go for 70%, 0.7, if we make it 70%, and then the implementation service multiplied by 70% as well. And then the OPEX is around 0.6 or 0.6%. Okay. So you can see there's an improvement in the OPEX, in the PP. So there are different factors how we can consider to build a new site. If, for example, there is 2,000 subscribers, so you will see that my OPEX are increasing, right? So that is part of being an engineer as well. So being an engineer not only gives you on the technical side of the solution. So as to become a solution architect, you need to have better approach on bridging the technical and the business side of the network. Because if you only focus on the technical side and then you're not thinking about the feasibility and the business sense of the network, sometimes it's very difficult to have an approval to build a site there. Okay, so that's why engineers are learning a lot more on specifications, new technology solutions. Okay, so we can get more equipment that is lesser in cost and implementation and maintenance cost. Okay, and then that's why Open Run gets a lot of attention on this one, because it will benefit operators on building more sites on those areas, especially on those rural areas. Okay, if we have low cost equipment, and then it will also give us more automation that will lower down our operations costs. It will give an opportunity for new cell site and new coverage to emerge. Okay, and what does it mean to subscribers? Because if you will think directly, the main benefactors are only operators, right? Because they will save in cost, they will save in maintenance or operations cost. So the main benefactors of this is operators itself, right? But if you look on the other hand, once operator will be able to deploy more cell sites, the end product would be the subscriber side. Okay, subscriber will now enjoy a more or a higher signal level or an LTE signal perhaps. So that's one of the one of the benefits of using this kind of solution. So yeah, so if implemented well, okay, and if we study it well, probably Open Run will be the answer to this kind of dilemmas that we we are encountering. Okay, I hope it I don't know, it gives you an overview on how this system, the Open RAN, will benefit the operator and as well as the subscriber itself and as a nation itself, right? As a whole. Okay. So if you're an engineer right now, so you need to think about technical and then how it will have a business sense to implement. Okay. All right. So we have these deployment scenarios. So we have the coverage extension or site densification. And then new deployments in urban or suburban areas. Okay, so we can also deploy that. System replacements and upgrades. So for example, in Palau, so Asia Open RAN Academy were invited to talk in Palau because they are planning to deploy an Open RAN system. And then they want to replace their existing system with Open RAN. So they want to learn more about how the Open RAN works, what is the difference of Open RAN to typical conventional or traditional network. So they are planning to replace their existing system. So can you also use Open RAN? Rural or coverage areas. Okay, so that is one of the um, um, solutions. When we say rural coverage areas, so these are typically for sites that are located at the last mile. No? So for example, you have a cell site here, no? You have a cell site here, have a cell site here, and then ang coverage mo lang is nandito, no? And then you also have some mga villages here that you want to cover. So when we say rural coverage, we can also build one site here, which is Open RAN. Okay. So this is one of one of the typical solution, but there is a concern here, no? But there is a concern here because in terms of radio network design optimization, we need to consider the handover. Okay, there's a lot of considerations, and as well as the connectivity in the core network. Okay, so but this is one solution that we can check. So probably it's still not so clear how to do it, but it's one of the solutions that we're looking at. Okay, later I will show you another one. And the support of private and neutral host networks. Okay, so when we say private and neutral host, so for a private network, so we can especially for 5G. Okay, so we can deploy 5G for private networks. So for example, one factory would like to deploy 5G, but this one is this one is sometimes challenging because unlike the US, they have an existing band. We call it the CBRS or the Citizens Broadband Service, which is in the 3.5. So a small investor or a small company can help those factories to deploy Open RAN, and then they just use this frequency. But here in the Philippines, we don't have that kind of frequencies. No, most of the frequencies are allocated to our major operators. Okay, so the deployment of private network will be depend on the private or on the operator side. Okay, so these are the different deployment scenarios now that you can think of. But maybe there's a lot of things that might arrive once you get immersed on the Open RAN network, and then you will see it when you also try to study it more. Okay, so if we build Open RAN, so connectivity, okay, so we can build connectivity on the network. So we can connect these phones and the some IoT devices. Actually, for the user side, you cannot identify if you're connected with Open RAN or not, no? Because it's the same technology because it's 3GPP standard. So your typical phone can work in an Open RAN system. You cannot feel that, no? Because it's a typical 3GPP standard. The only difference is that the software, the hardware, and the network is in open system. Okay. So there's a lot of Open RAN setups that you can check. So there are what we so-called the network in a box setup, okay, the NIB. So these are used for educational purposes and for research and development laboratories, especially for universities, especially for those universities who want to teach advanced communication networks. I believe if you will look at the curriculum of ECE right now, correct me if I'm wrong, no? Maybe other schools are getting uh, a longer leap in this curriculum advancement. I think pinag-usapan pa lang doon is 2G or the frequency planning. Let me know if I'm wrong, no? In the ECE curriculum. So if you're an ECE student or fourth year, so the technology that you're talking in your courses is probably most of it are from GSM. And in the GSM, you're not talking about frequency planning pa, no? So in some universities, particularly in abroad, they are using this lab kit. Okay, so they are using this lab kit. So universities are investing on the lab kit so that their students can learn the different protocol happening in the 2G, 3G, or in the 4G and the 5G network. Okay, and most of them are deploying already a 5G SA, a standalone deployment, because that is the future. So they are preparing their students to learn more about 5G standalone. Although here in the Philippines, we don't have yet a commercial standalone 5G. Our 5G deployment here is non-standalone, meaning we are using the current LTE network, no, as a core network. But later on, probably if opportunity comes in, probably operators will deploy Open RAN 5G standalone. Okay, so that's why some of the universities are investing more on the standalone. And the one that we are planning also in the laboratory are 5G standalone and non-standalone. Okay. Next in line is this interoperability labs or apps. So in some areas where like in the OTIC or in the University of Singapore, they are deploying this kind of system. They call it the interoperability lab. No? So you have a more comprehensive laboratory. So aside from this one, is just like a CPU and then a Wi-Fi router, but this is not like this now. So this is your core, and this is your radio, and then this is your UE. And then you can just study it, now study the protocols and then what will happen. But in this case, you can do simulation. Aside from a real device, you can have a UE emulator. So an UE emulator gives you a feel of what is a network, what is the network behavior. If the UEs are, for example, you can configure up to 1,000 UEs or more than 1,000 UEs here, and then you can simulate, no, if the network will be congested or not. What will happen if my network has 2,000 subscribers and then accessing a service, for example, accessing Facebook at the same time, okay? And then what will be the response of my network? What will happen to my network? So that is what we call the UE emulation. And then there is what we call the channel, RF channel emulation as well, no? So RF channel emulation, because we are avoiding the over-the-air transmission. So these are all connected via wire. So the RF channel emulator emulates the space characteristic. So just imagine if you are transmitting this over the space, and then there are villages, there are trees, okay? So this emulator will mimic that environment. And most of the time, they are using also this RF channel emulator if they want to test the distance between the satellite and your UE. So they want to emulate what will happen to the satellite signal from the space going to your UE. Because sometimes it's difficult, right? if you will do it actually, no. So they are using this RF emulator. And then of course there's system under test. So this is the ORU. And then you can also emulate the front hole, the distributed unit, the centralized unit, and the core. So if you want to have a 4G SA, 4G NSA, you can do the simulation here. You don't need to set up. You don't need to set up on actual site those equipment. You can set it up in the lab and then learn what you can do, no? What you will experience and what you will expect if you deploy it in an actual environment. Actually, this one is a good setup as well because before deploying it massively in your network, you will anticipate what will happen. Okay, so it will limit the number of failures or the failure or limit the failure rate of deploying an open RAN in a network. So that's why it's interoperability level. And this is a typical example of this is the architecture, and then this is a typical example. So this one is coming from Spirent, a US company, and Analog Devices. So this is an example of a plug fest done in TIP. No? So you have this automated platform control, so you can control everything here. So if you want to set up the emulator, you want to set up the core emulator, you all do it in this user interface. Okay. And then you have the core network for 5G or LTE. And then you have the front hole emulators. Okay. And then you have the ORU design. So if you want to check the design of your radio unit, you can also do it here. If before you do a massive manufacturing. Okay, so you can also do it here. And then you have this DUCU emulator. Okay. And then this is the UE emulator. Okay, so these are UE. This is how big your UE emulator is. Okay, so and then where you can configure a lot of UEs, more than 1,000 UEs now. So this is the architecture design, and then this is the actual setup. Okay, so once you figure out that this system will work, so maybe you can just propose it to your team, and then we can deploy it on a massive deployment. Okay. And then this is an example of actual deployment, no, as a community network. So this one is the one that showed also by Sir JP. So this deployment in an indoor, you can deploy it indoor, or you can deploy it outdoor, like this, no? Or you can do or a combination of outdoor and a rooftop solution. Okay. So those are the different open RAN setup that you can see right now in the system. Okay. So who are already available in the market? Okay. So who are the players? And if you're an engineer, who are my potential employers? Okay. Who are my potential employers here? No. So there's a lot, no? There's a lot of you. As we mentioned, as we always mention, the Open RAN is the culmination or the intersection of the two skill set. It's a intersection of telecom and IT. Okay, you can see there's a lot of telecom vendors and also IT. So that's why it's called the ICT environment. No? So there's a semiconductor chipsets. So we need to have the semiconductor chipsets to manufacture the equipment from the UE and going to the RU, DU, and the CU. Okay, so these are the typical or the common names. No, so you have the Intel, Qualcomm, okay, and Analog Devices. Now you also have the ORAN hardware. Okay, so including the radio units. Okay, so typical is Mavenir, CommScope, and we also had the full RAN like Ericsson, Nokia, and Samsung. By the way, Nokia and Ericsson started to open their baseband unit, to be able to connect it with an open radio unit. Okay, we have the software companies for the RAN software, the RAN intelligent controller, and the SMO. The services as well, like the integration, and also on the cloud. So if you are involved in any of the cloud vendors here, and then you're trying to learn their system like AWS, Google Cloud, Microsoft Azure. So you're on the right track. No, you're on the right track because in the future, if we deploy it massively here or in the other countries, so one of these might be the vendor that the operator is using. Okay. So this is already what is already in the market. And how is the global landscape? No, it's happening. So what's out there in the Open RAN network? Now, if you go to ORAN Alliance, no, so this is the ORAN Alliance website. You just type it in www.oran-ran.org, and then you can just click the ORAN map. Okay, so you will see the world map now, and then you can see the different locations where Open RAN is being tested. Okay, you can just click when is Open RAN is being tested, field trials, deployments. So there's a lot of deployments already, and the pre-commercial launch. Okay, so there's a pre-commercial launch in Taiwan. It's only around less than 2 hours siguro. No? Commercial launch. Okay, so commercial launch, if you will look at it, we have a deployment in US. So Dish is one of them. So Dish is already launched in June 15, 2023. Okay. So they have a 5G NRSA with 15,000 sites. Okay. So if you want to learn more about them, you just click here, the original announcement. If you want to go to Latin America in Peru, there is an IP Telefonica MetaBid investment. Okay, so there's already commercial launch. In Vodafone, what is it? In Serbia. Okay, what is this country? Oh, in Romania, no? So there's an Open RAN in Romania. Okay. In Italy, okay, Telecom Italia Mobile, and in Netherlands. Yan. So, 1-on-1. Yan. So, kung gusto pumunta ng Europe, meron ng Open RAN doon. Here in the Philippines, wala pa. But here in Japan, you can see 3 distinct operators are commercially launched Open RAN. KDDI, Rakuten Mobile, and NTT Docomo. Okay, so you will see a lot of opportunities now. So if you're the type of person that would like to explore the world using your skill set and knowledge, just take the opportunity and bring your skills with you. Okay. Bring your skills with you. That's the key word. And you can go around the world. That's why we encourage you to build more skills, right? Build more skills in telecom, build more skills in IT. So the more skills you have, the more opportunities you can get, and the more places you can go. So when you go, just get your skills, pack your bag, bring your skills with you, including your backpack. All right, so this is the status of Open RAN. So if you want to explore this more, I'll share with you the link. Okay, I'll share with you the link.